Today's episode is brought to you by Engineering.com, a globally trusted source for engineering content. Check out this and many other exclusive videos for the engineering professional found only on Engineering.com TV today. You know, President Biden's CHIPS Act promises to do something that is widely regarded as essential for U.S. economic and military security in the 21st century, and that's to reestablish control of the manufacturing of critical high-end semiconductors. Billions of dollars have been spent to attract major manufacturers such as Intel and TSMC to new build facilities in the U.S., and the facilities are expected to employ the latest in production automation. But semiconductor manufacturing is still labor-intensive, and the labor needed to produce integrated circuits in the single-digit nanometer scale is highly skilled and specialized. Are there enough workers with the necessary skills to support this production in America? To discuss this important issue, I'm joined by Dr. Parminder Jassal. Dr. Jassal is CEO of Unmudl, a leading skills-to-jobs marketplace for developing skills through hands-on training, propelling workers into job roles with American employers. Dr. Jassal, welcome to the Primary Loop.
Thanks so much, Jim. It's great to be here.
Parminder, it's so much to talk about this. I mean, this issue is so critical. This technology, advanced single-digit nanometer semiconductors, it's widely considered to be the critical enabling technology for AI and for almost everything that will underpin the economy in the 21st century. And I can understand why there's an urgent need to sort of reshore it and bring it to a secure place. But how big is the problem of establishing employment levels with skilled people to actually make this work? Can you give us a sense on a sort of a grand scale of just how serious is the issue?
It's very, very serious. So if we rewind 15 years ago, that's when President Obama began investing very, very heavily into STEM, the STEM movement that everybody heard about back then. We had billions of dollars through Educate to Innovate back in 2009, starting to invest there. That was 15 years ago. So you can't have a conversation about the seriousness of the industry, especially the semiconductor industry, without thinking about STEM and technicians. So when you start looking at industry overwide, the go-to places are the National Semiconductor Technology Center, the Semiconductor Industry Association. They are projecting anywhere around 100,000 workers shortfall only in the semiconductor industry for new jobs. Now you start adding attrition. We're looking in the range of more like 125,000 shortfall. Now you start thinking about the ripple effect in industries like telecommunication or renewable energy and solar cells, AI, medical devices like imaging systems, or aircraft. Any type of labor shortage in semiconductor skill sets also impacts there. So we're looking at to the tune of 145 to 250,000 worker shortfall.
Wow, that's a huge number. Now, half a century ago, when America dominated this industry as it then was, there was sort of an informal training ground formed by the major corporations. So Motorola or Texas Instruments, Fairchild, later Intel, essentially they formed a place where young technicians, engineers could sort of cut their teeth and learn the skill and then work through the supply chain from there. In this case, we're sort of almost restarting from scratch. So how do we nucleate that? I mean, you can't just sort of go to a trade school and say, by the way, we need 4,000 millwrights who are skilled at handling, wafer handling.
Yeah, you're exactly right. I mean, that is such a key issue right now. And I think one of the top things to remember as we kind of think about national strategy, at least, even with the return onshore of manufacturing jobs, just that alone has projected a major shortfall as well. So when we start adding up all these shortfalls, what you're talking about, having a really national strategy on addressing this, we look at the three top states only for semiconductors. That would be California, Texas, and emerging as Arizona. That's actually like blasting forward. That kind of represents like a Southwest type of strategy, but we also have hot centers in Ohio, in Oregon. So people don't move. When you think about like, what's the breakdown of all of these shortages? Take maybe about 33% into engineering, 33% into R&D, and you're looking at about 33%, maybe even up to 50% that comes under this emerging new layer in the workforce called technicians. Now, what are technicians? Technicians are those that have these skill sets like engineers, but they get their hands dirty. They get hands-on, roll up their sleeves, not always literally, because if you're working on a robot, you might not be doing that. But you're in there. You've got your hands on, you're practicing safety, you're using a spectrum analyzer, you know how to do QA, you know how to communicate. A technician skill set is very basic, yet very broad, like an engineering skill set.
We're talking about a strategic industry which is national in scope and national in importance, and you've just identified that it will tend to be focused on several states. Is this a state-level training education program? Should this be operated at the federal level? Should it be federal money flowing through states and local areas? A local community college, of course, is looking for money everywhere. Where should it come from?
Yeah, so I think that great amount of money that has come through the CHIPS Act, that $39 billion, there is a set aside for workforce and talent development, especially at the engineering, R&D, and then also at the technician level. So a national strategy, at least coordination is needed. If you think about the community and technical colleges, we have over 1,000 of those here in the US, but they're not working as a powerful collaborative unit at the moment. They serve local needs. So really leveraging a skills to jobs type of theme that produces technicians is one way to do it. Apprenticeships like at Foothill de Hanza, right next to Apple there, Central New Mexico Community College and Albuquerque with their skills to jobs approach, which is very low cost, directly working with employers and reverse engineering from roles that are needed. Gateway Community College in Phoenix, Arizona, working on partnerships with Taiwan semiconductor manufacturing. These kind of fast track programs that they put into place are amazing. In Texas, Austin Community College, working on, which is a very concentrated semiconductor corridor, working on apprenticeships and skills to job strategy. That type of coordinated approach that allows for co-opetition among companies is really crucial.
Parminder, we're looking at rapid construction of these facilities, and by rapid I mean just a few years. These things will be up and running. Will it be possible to train up a cohort of young Americans to take these jobs, or are we going to have to look at a green card strategy, it's kind of like the way the coders do, and look globally for people to infill the gap in the short term?
Yeah, you know, I think we have to look at that. There's no doubt. The issue is technician level gap is our largest gap. We produce a lot of STEM degrees and STEM graduates that are higher level talent, but where these huge facilities need talent is at that technician level. So I think there's a grassroots strategy, which is these community and technical colleges, they've got to get on the ball, but not as individual units where you can't scale, because we can't have a class of 5 or a class of 12 or a class of 20. And on top of that, we need to make sure that, number one, semiconductors is not the only manufacturing industry in our nation. We have so many other companies like a Johnson & Johnson. We have Tesla. We have so many others, Chevron. All of them need technicians as well, too. So you can't poach. You've got to reverse engineer from the employers, and the employers are going to have to come together rather than all of these separate strategies that they have out there. I think co-opetition is really the name of the game to exponentially increase our workforce size for technicians.
So much to talk about, so little time. One last question. Parminder, I come from manufacturing. There's no place I would rather be. It's a brilliant career. I think it's a brilliant career for anyone. I tell every young person I meet exactly that. Is there a sales job necessary to get young people interested in this. It's intrinsically fascinating. We're talking about semiconductor manufacturing. It's the future. It doesn't get more Star Wars than that. Do we need to sell this hard, or does this sell itself?
So I think it sells itself, but here's the problem. You've got to know about it. How many people grow up thinking, oh, you know what? I'd love to be a semiconductor technician, or I'd love to be a robot watcher and manager, or you know what? I would love to be a medical imaging technician. People don't think about that. It's not that they don't want to go there. And that's what we're finding through Techs of Tomorrow, which is a national conversation that we have launched, starting with Albuquerque, New Mexico, with Central New Mexico Community College. And we're going community college by community college, state by state, to really talk about the emergence of this technician layer of the economy. It's an emerging workforce, and it pays really well.
Dr. Parminder Jassal, Unmudl, thanks for joining me today on The Primary Loop.
Thanks so much, Jim.
Well, that's it for this episode of The Primary Loop, brought to you by engineering.com. For our deeper engineering series, visit engineering.com TV for exclusive shows like Manufacturing the Future, Designing the Future, and the Engineering Roundtable, not found here on our YouTube channel. The links are in the description below. Thanks for watching.